The University of Arizona's Sarver Heart Center in Tucson has found that some patients with artificial hearts have experienced heart muscle regeneration at significantly higher rates than seen in healthy hearts. Dr. Hesham Sadek is the director of the U of A Tucson's Sarver Heart Center, and he joins us now. Welcome to Arizona Horizon. Good to have you here.
Thank you.
Let's talk about this. So the idea is that your research focused on people with artificial hearts, and what did you find?
So my research focuses on making the heart muscle grow. So in humans, the heart muscle doesn't grow after birth. In utero, the muscle cells divide and it grows, but then after we're born, there's very slow rate of turnover, maybe 1% per year. And so if you have injury to the heart muscles, such as a heart attack, for example, that 1% per year is not enough to regenerate and regrow the heart muscle back to healthy function. So we're working now on trying to find ways to stimulate the heart muscle to heal itself, and by having the heart muscle cells divide. What we found was that the artificial heart, which is supposed to replace the heart pump by rerouting the blood away from the heart, some patients who have it actually have up to 6-fold increase in cardiac muscle cell division.
Now, first of all, why is it so difficult for the heart to regenerate? Is it just because the doggone thing doesn't stop working? Is that really what's going on here?
Actually, you hit the nail on the head. That's exactly why. We think that because the heart after birth takes on a very strong function of pushing blood at a very high rate, at a very high pressure, 120 millimeter mercury in a normal heart, that makes the heart very energy hungry. So it builds up its machinery to consume oxygen, and it's the highest oxygen consuming organ in the body, builds up this machinery, and as a result essentially burns its DNA, causes oxidation. And when that happens, as a protective mechanism, the cell can't divide. And so when you rest the heart by putting an artificial pump, it essentially goes back to in utero condition.
That's what we're going back to with the artificial. You guys discovered that with an artificial heart, it lets the heart take a nap. It lets the heart regenerate. Is that what we're talking about here?
Exactly. We think this is what's happening.
How surprised? Was that something that was thought or considered previously? Was it a surprise?
So we had published a paper, I think maybe 8-9 years ago now, where we found some indices that heart muscle cells can divide in these patients. But what's new in this paper that was just published is that in collaboration with the Karolinska Institute in Sweden and University of Utah, we found that using the gold standard, which is essentially carbon dating, like what we do for dinosaurs, for example, we can carbon date the cells and determine the age. And that is really the gold standard. This proves without doubt that heart muscle cells do divide in some artificial heart patients.
What does this mean now for the treatment of heart failure?
So now it means that we can use the artificial heart not as a therapy as a bridge to transplant, or as a destination therapy, as we call it, in someone who cannot get a transplant, but maybe as a means to regenerate the heart, and maybe we can remove it and the heart can be healthy after that. Now, that happens already in some patients, which is called bridge to recovery, but we have no idea why that happens or why some patients do that.
I was going to ask you, give me a percentage of patients where you actually see this regeneration?
So of the patients who get artificial hearts, about 25% of them can recover their function.
Is there any idea as to why it worked for them and maybe not for the others?
Absolutely not. This is the first evidence that this may be. So in this study, the patients who had increased turnover were the ones who recovered. So the ones that had artificial heart that did not recover did not have an increase in turnover. So this is the first indication that maybe this recovery is because the cells divide.
So what's next in the research?
So now we have to actually put in protocols that measures this. We can measure this in vivo without having to take a piece of the heart out using imaging techniques. And so we need to do this prospectively. So image the heart, try to monitor the increase in cardiac muscle mass, and determine which patients and when can we actually wean them off the pump.
We do a lot, last question here, we do a lot of stories, health stories here, and there's always such breakthroughs. Some not so much, some a whole lot. Heart studies, seeing a lot of breakthroughs these days?
I would say in the past few years, yes. We've had several heart failure drugs for the first time in 30 years.
Wow.
And so I think research is pushing the envelope, and I'm very excited.
Dr. Hesham Sadek, again, U of A College of Medicine, the Sarver Heart Center. Thank you so much that's an encouraging story. Thanks for joining us.
Thank you.